So let's get started. This is a chalk, so it's, well, we have some things that we have prepared to kind of get the discussion started, some different topics that we would like to go through just to give an introduction to various things. But then it's your opportunity to ask questions about this is about MRP. We'll go through some of what have happened on the intercompany planning. We'll go through the scheduling engine architecture, what has happened in that regard to MRP. And then if we have time, we'll go through there's some few scheduling parameters that we've added. But just shoot all your questions if you have them. So my name is Anders, and this is Roxana.
Hello.
And she'll get started on the intercompany planning first.
So, welcome. And I'd like to start by asking you a question. Have any of you used intercompany in previous AX versions, so 5, 4? Okay, good. Does anybody want to share the usage scenarios? How were you using intercompany? Yes, please.
We manage basic flow, I could describe like
yes.
this, intercompany. That means that we set up endpoint to exchange, because we have one central, one supplier, one central company, and which provide some seed, because we are seed producer and other subsidiary. But so we manage basically sales order, which transform in the purchase order in the sales company. We manage return also, so maybe it's complexity because we are in version 4, so no really return management. And after talking about the MRP, we are a little disappointed that finally this different company exchange only when they are confirmed proposal, and there is no exchange on the forecast level. I imagine that in 2012 it's better. So our frustration comes in that even in version 4 we could synchronize some MRP calculation. Only if we set up some short confirmation period, if we want to exchange between these different MRP calculations, is very, very difficult. That's why our expectation is, in fact, we imagine that master planning in our context, because we have not only, as I described before, one main company which produces for the other. We wanted, since the beginning, we tried to search a solution that which could consolidate on the input point in the MRP, I mean stock forecast, and try to manage a global master planning and to launch to the local master planning. And it's not the same to try to synchronize different MRP.
Okay, so basically what you're saying is that supply and demand were only connected for a short time, and they were only connecting once they were firm. Yeah. Okay, this is actually something that we changed. So in AX6, the biggest improvement we made to intercompany planning is that demand and supply can now be connected even when they're planned. We connect planned demand and planned supply. This is the first major change. Second major change, you are now able to explode requirements in the whole supply chain. But I have to be very clear on one thing. When I say supply chain, I mean internal AX enterprise supply chain. So if this here is a supply chain, when I say supply chain, I mean only this. We are not planning for external customers, external vendors. So this is why I don't want to use the terms vendor and customer. I prefer using upstream, downstream. Downstream are your legal entities that create the demand. Upstream are the legal entities, the production plants, the distribution plants, whatever. So this is our internal AX supply chain. What happens actually is that, let's say that this is your sales subsidiary in France, let's assume. And the sales subsidiary will do a demand forecast, and they will run their internal planning, and they will get planned purchase orders, and the planned purchase orders will probably be for either a distribution entity or a production plant somewhere. And so for the first time in AX6, the plans that are coming from the sales subsidiary are transparent to the production plant. The production plant or the distribution plant can make its plans taking into account planned demand from the sales subsidiaries from here. Also, if this is just an assembly plant and it uses some components produced in a third AX plant, then after MRP is run in here, the plant demand becomes transparent for the third plant. So now requirements have been basically exploded all the way and are transparent all the way. In here, you see that you need to plan capacity, because this guy plans to produce a certain number of products because the sales subsidiary forecasts to sell a certain number of products. Visibility throughout the chain. In order to support this, we have introduced three. You had a question? Sorry. Yes. The relationship is planned intercompany demand. So we will get to that. This is so three concepts we've introduced in AX6 in order to support our new story. First concept is the intercompany planning group. The intercompany planning group is basically a collection, a group, in which you add all the legal entities that are part of the supply chain that you want to plan at once, for which you want to generate an integrated plan. And I'm going to show you exactly how you set it up in AX. So in my scenario, I have just two legal entities. I have a CEU, that's a production plant in the United States, and I'm making hi-fi equipment. And then I have a sales subsidiary in Europe. And if you go to master planning, you have setup, and in setup you have intercompany planning groups. Intercompany planning groups are enterprise shared data, so it doesn't matter which company you are in when you do the setup. I happen to be in CEU, but this is not important. So in here I have two groups. They're named dynamic and static. Let's analyze the static group. In the static group, I have the sales subsidiary. It's the first member of the group. So it's the company where demand comes from. So it has a sequence order, a lower sequence order. And then I specify the plan that I want to run in this company when exploding the demand through the supply chain. Then I have the production plant. It has a greater sequence number. So first I need to get the demand, and then I know how to supply it. And I specify the plan I want to run in the production plant. Okay, any questions? Yes. No, no, it's just our data that's not very well optimal. It's any plan in the legal entity that's part of the group. So it just happens to be that in both companies, in both legal entities, we have a plan called number 10. Yeah.
And if you have the sequence number is
Yes.
unique, that means that you have
Yes.
That means that if you have several subsidiaries, you have to predefine before an order in this requirement consolidation.
Yes.
And it's a new because if you compare with the classical master planning, if you have in one company, you consolidate all the needs of your customer, not defining an order or priority in this requirement.
Yes, the thing is you can run more groups to fit these needs. And also later we will discuss about something that's called a downstream plan. So let me get to that. Second core concept introduced is the planned intercompany demand. And that answers your question. What are those? Are they purchase order? No. That is planned intercompany demand. It's basically a new type of demand. And it's the planned orders downstream that are reflected as demand upstream. And I will show you this in AX. Exactly. It's a transaction, basically. So in AX, I am still in my on the production plant. I'm still on the master planning, and I have inquiries, intercompany, incoming planned intercompany demand. And what I see here, well, this is basically this. Oops. Doesn't work. Anyway, this downstream planned order, this is the information that's coming from downstream, from the sales subsidiary. In the demand details, you see the conversions, the data, the transactional data that has been converted to meet the requirements that I have on the production plant. And there I see a list with all that's coming in the master plan that I'm looking at now. It's up there. Unfortunately, it doesn't work. But you'll get to understand it better once we get to the demo. And finally, our third core concept is the concept of downstream source plan. This is very useful because it allows you to pick up planned intercompany demand without running a full intercompany plan. You just do a regular master plan in your company, and all the planned demand that you have registered gets picked up. I will show you. I see you don't really understand this, so we go to X. It will be more clear. So we are still in master planning. We go to setup, plans, master plans. And in here you have all your plans, 10, 20, whatever. Let's pick plan 20. And here we have a new tab, Intercompany Planning Tab. And first thing that we have is a flag, include downstream planned intercompany demand, yes or no. If you say yes, include downstream planned demand, then whenever you run master planning locally for plan number 10, all the planned demand coming from the legal entities that are in the list below will get planned for, will get taken into account. So in my case, whenever I run plan 10, all the planned demand coming from company CEE, my sales subsidiary, will get planned for. No, I'm running local plan, local MRP. Yes. Yes. So let me do a full demo. We will start from the, we'll change to the sales subsidiary. And in the sales subsidiary, well, actually, in the whole enterprise, we are dealing with hi-fi equipment, and one of the products we are selling is home theater system, and the product name is 16. Now, you can see that this product, 16, it has been released in two legal entities, on the sales subsidiary in Europe and on the production site in the United States. The name of the items in the legal entities are different. So in the sales subsidiary, the item number is 16. In the production plant, I'm tracking this product with item number 1201. Now, in the sales subsidiary, I have registered, I have taken a sales order for 1,000 items, 1,016 items, so basically the home theater system product, quantity 1,000, and the delivery is calculated to be 23rd of November, based on the lead times and so on. Internally in the sales subsidiary, I'm running master planning. So I'm going to master planning, periodic, master scheduling, and I'm running plan 10, let's say. I will not do it now, it's a lengthy operation. And we got planned orders, and one of the planned orders is for this item, number 16, quantity 907. This is 970, this is because I already have on hand. Pegging from the sales order, and the vendor is 9100. So who is this vendor exactly? This vendor represents Contoso Entertainment Systems, which is basically the production plant, the legal entity representing the production plant. How do I connect these? Well, through intercompany trading relationship. So what's written here is that between vendor 9100 in the sales subsidiary, I have a trading relationship active, and it points to legal entity CEU, my production plant, and the production plant holds a reference towards me, the sales subsidiary. I am a customer, and my account number happens to be 9100. Again, our data is a bit tricky. This number here could be any. Now, if we change back to the production plant, we will go to sales and marketing, all customers. And here we find the sales subsidiary. And the trading relation that we set up in the sales subsidiary, we can visualize it here as well. It's again, same data shared. Here it's inverted, of course. The production plant holds a reference to the sales subsidiary, and the account number is visualized as customer number 9100. Oh, not good. Let me open this again. Okay, so in the production plant, as you saw, plan number 10 was set up, plan number 10, so number 10 was set up to take into account planned demand coming from the sales subsidiary from plan number 10. So if in here, in the production plant, I run master scheduling, plan number 10, normal run. I will not start it now, again, it's lengthy operation. In the end, I will get a planned production order for 970 home theater systems. which in my system is item number 1201. It's essentially the same product, a home theater system. And what's interesting to see is that why do I have this planned order? Well, because in my sales subsidiary, they plan to sell this number of home theater systems. So, yes? Yes. If you go to View, Multi-Level Pegging, you will see, let's look downstream. So I have this, I need to plan for this production because in CEE, they plan to sell this. Now, also, you can look what's happening upstream. Let's say if I had another company producing the components, another X company, legal entity producing the components. When I look upstream, I see explosion, upstream. I see what they have to do in order to meet my requirements so I can meet the sales subsidiary requirements. In my case, I just need to purchase and transfer some items, either from my own sites, so it's not very interesting. But this is, this form shows you exactly what you wanted to see, the explosion, the full explosion in the internal supply chain. So basically, this is it. This is how it works now. Yes? Yes. It's the okay, so the site is taken from default order settings. Because the moment you release the same product into companies, on those items, you can define default order settings and lead times and what have you. So that's where the site information is taken from. The moment you create a planned order for item 1201, I look default order settings, I take the site and warehouse from there. Yes? Okay.
Is there an option for the planner to say, this demand I can take it here or here?
Yes. Can you help with this?
Right now we have no automatic distribution of this. In it goes to the level on there that have to change to
Yes, yes. So he can do that.
In addition, I'm a customer, and when I'm the planner of the intercompany, then I don't want to decide which item can produce in company A or B or C. The best way would be that the system decides there is the capacity in company A, and that is able to build my product, and that would really help me in the intercompany process. The framework is there, you just don't have the implementation. Is it already planned? We cannot disclose product roadmaps, but I can tell you from our point of view, here from manufacturing team, it's one of our high priorities. I can't say whether that makes it to the next level, but for sure, I mean, the base desire, how modern the company and it's out of communication with the not there. Yes, this is for sure a very, very important part of our work. And unfortunately, I cannot say I'm not allowed, and we don't know yet. I mean, it's 3 years at least till we achieve the next version.
Just to position it, so we can do now what we call rough capacity planning. I mean, I can take this plan and put a site against it, and go to that site and see what's happening to the demand, right?
Yes.
To the capacity. If I don't like it, I can just go and change it.
Yes.
Visit the second plan and just see the. So this is manual planning, but we can still do that, right?
Yeah, manually you can do it.
And that's really
But just to be sure to understand what is missing is when you say it's possible to change, we see in this demonstration that two company MRP is linked. For us, this changing, this manual changing is possible in the CEP or in the CEU because both.
Both? Yeah.
There's a plan order that has a source and a end, right?
Yes.
So you can just say, this is the source, but the production can be different, right?
Exactly. Yeah.
So this is okay, I think, for our customers, until they wait for that automatic optimization.
I totally get it. We would like to do this. But I think we build the right framework to the data about before. And if there's any partner here, where you've done it in 3 years, there we go.
There are third-party products that can take this and optimize this for that.
They were at the beginning of the art decided they were all okay, we need this, we have to plan.
Yes.
And then after you build this and then you start looking at this, for example, reactor or some other scheduling tool, and then they run this and something comes out and then they ask, how can we trust it? This is optimization and you can't, there is no, because they I don't know, they had manual planners and guys for 10 years, they have they say, okay, this is I know that this customer, or this vendor is always this, and then they just stop here.
To that point, of course, what we actually that's your opinion how for the customer can use what they are. But our approach is really we rather want to build the execution part before the planning part. I mean, we see other systems that do the market planning and never create to actually execute what we plan. We rather want to say, okay, if we make sure that the execution chain is in place so we can actually do what we are really and actually execute according to what we plan, make that before we actually optimize. And that's basically the approach. Whether it ever will become reality to optimize on something I believe it will, but I get you right a lot.
Now they're packing.
Yeah.
2009 already.
Only very mature organizations can trust optimization. All the
But
others-
Anders will talk about later with how we have to get insight into how we do the plan.
I have one question.
Yes.
So, to have visibility of demand, it's only plan orders. You cannot send forecast.
Yes. Forecast planning.
Forecast planning without
Yes.
having plan orders.
when you run forecast planning, you get, you are the forecast master. We have the forecast master in the room.
Just let me know if you're skipping through. So, significant changes 2012 as well. You don't have to run forecast planning anymore.
Oh,
Within master
there.
planning, you can actually do forecasting, and we can load forecast numbers. So basically, if you want to forecast in CDE, selling this multi-year system, #16, we run that to generate planning of company demand in CDU. We have a parameter on both, so there's a lot of new things about forecast production, but just to say there's an option to include forecast demand from sales materials, and whether that should reduce your forecast in CDU, because assume that CDU forecast that I'm going to sell 1,000 of item number 1201, and this sales subsidiary decided to sell 500. So should that reduce on top? I mean, what should the total forecast be? So in that case, you totally have the forecast flow, and we can actually do forecast production on specifically under the company.
So the sales offices can forecast their plans. I can aggregate them to a central one.
Exactly.
Do a simulation, and when I'm happy with it, I can send it back to the production. That's really what that central.
Essentially, yes.
Okay.
Yes. I mean, but important here is that yes, we can do forecasting in sales theory and in production side for the same product, and we can use both in and. And there's some new things about forecasting on the lower levels used on the sales office.
Okay.
Questions?
Oh, another question.
When do you have to use a local master plan, and when do you have to use an intercompany master plan? What are the differences between them?
It's all just local master plans that are connected.
So,
When you set up master planning group, it's just five or local master plans in the sequence.
So this is basically what's happening here in the sort of behind the scenes. What we're basically doing is we're starting out. I don't know.
doesn't work.
Okay. So we're starting on the left side. Basically, we're logging some plans. We are performing some checks. Then we change the company to whatever company it is. So if you're doing this big master planning intercompany run, we change the company. We basically just trigger off a normal reg calc, which is basically the master planning run. That reg calc is doing some tasks. At some point, the interesting part in this intercompany thing, actually what we've only had to add is that we insert the intercompany demand from the other companies into this new plan, and then master planning goes around, runs as normally, and then we basically just go to the end, change to the next company and so on, and then we're done. So the only thing they're exchanging, information they're exchanging, is these intercompany plant demand.
This is insert intercompany, and the term is aggregated.
Yes, this is
Yes.
the method called,
But that's the name of the method.
this is the name of the method actually in RegCalc. So. And
Yes, yes.
it says log plan versions.
Yeah,
Yeah.
yeah.
It's a thing you will never be surfaced to from the user.
But
So basically, for each plan, there's two versions now. There's an active and an inactive. What we're doing is we're actually generating master plan in sort of the inactive versions. Once we're done, we're flipping. And then the inactive becomes the active, and then we can do whatever we want. It also helps a lot of performance about this deleting plans that we had a lot of trouble with before.
So the only time you lock data in data from your master plan is the time it takes to do it.
Yes.
Yeah.
So I don't know if this is the right one to discuss this, but we have instances where a site is actually its own server. How does
It's its own database or own OS.
Database level.
So this is only within master planning or intercompany master planning, like this, is only within one database. This is the limitation. So if you have to do it the other way, you have to do it through firmed and so on.
Okay.
Okay. So, yes?
Are you able to take costs into consideration on several sites, deciding which one is the cheapest one, or
Okay, so further optimization basically. But on cost, no, we don't have optimizations now. Any comments? Ulrich?
So what we build now is a scheduling engine. So what you see here is this kind of open up for different kind of optimizations. This is the optimization we're planning that we could do in this area is more like the actual resource scheduling optimization. The other one, the other purchase buy decision, it's a very sensitive kind of decision to make, right? So.
Basically what you say, we had this question before, which site do you have? And let me say, when we are building that optimization logic, we are first following two main decisions, lead time and cost. So it's not the first time we have heard that those are at least the primary reasons why you want to change the site, that's lead time and cost, and then of course capacity cost. Basically lead time and cost.
No, but there's capacity and there's transfer lead time.
Yeah,
Have you taken
lead time to get the product to the customer. Yeah. I mean, we have not made any perfect already, but I'm see what the engine is capable of.
This parameter is still a general parameter and it completes optimization by time or process goes into the plan.
Okay, right now when you talk about the current functionality we have, you can only do trade agreement with cost of lead time, that's the general parameter. The thing we're talking about for future workers would be per, I guess it will be per supply volume, because it's really a product. So, but again, that's future, we haven't made that final design. So for now, we have no other optimization than you can certain trade agreement by entire
those data is available at the time?
Okay. So let's try to move on. What I'll go through now is the new scheduling in the architecture. I know the title of this session it has something to do with MRP fundamental changes, but what we've actually changed is more the scheduling part of it. To do that, we've also had to change kind of the flow, or a little of the flow, internal flow of the MRP code, how it runs. We've done some changes in the way we call it tasks now. You can remember in 2009, you can remember this magic number, the helper item distribution factor, which if you run multi-threaded master planning, the way it would distribute tasks against or jobs against each kind of AOS and so on. We've done some internal things there. I will not go through that now because it's more or less, I mean, if you look in the code, it's pretty easy to kind of see what's going on there. So these are, what I'll go through now is the more generic changes that we've done with regards to scheduling. So the first thing we've done is we have split, once we talk about scheduling, we basically talk about three different parts now. We talk about what we call the X++ consumers, which is basically any kind of activity that needs something scheduled. In this case, we have three. We have the MRP, the production scheduling, and the project scheduling. This is the hour forecast. So each of these kind of overall processes, what we've done is we made what we call a pre and post processor for each of these. This is basically something, the whole point here is that we want to make something generic that we can transfer into the lower part here. So for each, let's take the MRP one. We have a class, works in a scheduler REQ, which is kind of master planning class, which is inheriting from works in a scheduler. So And in the bottom we have the new C# code. So the scheduling engine now, the core sequencer, if you will, kind of the job sequencer, the one that finds out which resource should the job run on and what is the sequence they should be in, where should they place time-wise. That has now been pulled out of the old code and is now placed in a separate assembly, .NET assembly. So what will happen is that this kind of scheduler class will basically push some data into the lower layer, or into the bottom layer. It will put something that we call jobs, job constraints, inter-job dependencies, and some applicable resources. So if you take the first one first, the jobs is basically any kind of activity, the smallest part that you can think of, an activity that takes some amount of time to perform. So it's some task that needs to be performed. And when we say job, we really, it's not like if you look on the production order, you have the jobs. It's actually even more fine-grained than that. So if you have, for instance, parallel operations, you will have one job per operation, and it's basically the lowest, the most exploded job you can think of. Then we have we have something that we call a sequence. So basically, if you have two jobs like process or setup and process, these are in the same sequence. So we basically give them the same sequence number. Then we have the dependencies between these two jobs. This can, for instance, be that they how they are linked. So this one has to start after this one finishes, or these two have to start at the same time. They have to finish at the same time, or so on. This is what we call the inter-job dependencies. Then we have a number of constraints, and I'll go through exactly what kind of constraints we have later. But a constraint is basically something that limits in which period the job can run on. So it could be that we have a start constraint, basically saying you cannot start before this date, or you have to end before this date. And we have something called the applicable resources. How many of you were at the session I had yesterday about okay, perfect. So this is basically, we have some code that determines which resources could potentially be used for this job. If you, for instance, on a production route has specified a specific work center or a specific resource, it's kind of, well, there's only one that you can use. But if you're using this new thing with capabilities on the job or on the routes, then there will be a number of resources that could potentially perform this job. So what we're passing into the engine is which resources could potentially perform this job. The engine, once you call run on the engine, it will basically ask back into the Express process code for some more information. What it will ask for is the resource capabilities, which is basically what properties do the resources have, and in what kind of time period do they have these properties. So the scheduling engine is actually the one that will match these kind of requirements we put forward to the actual properties the resources have in the given periods of time. So these properties can come from anywhere. It can be HR skills, it could be capabilities, it could be whatever you can come up with. It will also ask for working times. So these are working times according to calendars adjusted by efficiency or however you want to adjust it, basically. And finally, there's the existing capacity reservation it will also ask for. Then what will happen? The C# engine will do its magic, and then it will return which resource was selected for the job and what time should it run. And also the individual capacity reservation. So you know if you have a job that you will run from 8 to 4, it most likely has two capacity reservations, one from 8 to 12 and one from 1 to 4. So these are basically the information that will return back. Yes?
The different time calendars of in the company plan, for example, one company is Russia, the other one is today, Germany, and so on, will be used in the new MRP too?
So the C# engine works on UTC time, which meaning it works on any kind of time you pass into it, it has to be UTC time. So you basically convert it into UTC time, and the engine really doesn't care what time zone you're in and so on. But currently in MRP, we do not have the notion of different time zones and different sites, for instance. We don't use that. But the engine is capable of doing that if you have this.
So the result would be that the MRP would plan in the wrong time, or I don't understand how the MRP would plan for Russia or for the US.
The MRP basically will run in the time zone that you have defined for the current company. In the legal entity.
Okay. So it would be planned on the right time, isn't it? Okay.
Yes.
So basically, this is significant uptake of time zone.
Pardon?
We basically uptake time zone definition in If you run a company relation, it's not really an issue. If you run, let's say, a US-based company, one legal entity, multiple sites, where each site has a different time zone, or Russia, you have a problem. In that case, with a political, you would have to either accept privacy or use a company instead of a site. Okay.
Let me give you an example, because that's a very important point. I am releasing an intercompany production site that's in the UAE, right? In the UAE, they're close to Friday. My planned receipt of an originating site says 8 hours later for receipt of product, but they're closed. The only day I can receive it is 3 days later. Would that take into consideration?
It's in the company that you take it. But if it's with a multi-site, no. Yeah, but the thing is that if it's a company, if it's multi-site, it's transfer over, and you don't have time zone notation on your code. So that's the thing, and we don't control. Because, I mean, that should be, at least it's the scenario we work towards in this company time. So I mean,
Yeah, but
we're not doing that because the legal entity time.
if it's a separate country, it should be a legal entity, so it is multi-country.
Yes, but if it's within a, you have countries that are different size, or you have time zones where you could use site as, then you have a problem.
Canada, US.
Yeah.
Selecting resources and capacity reservation, the reservation is being the same level as the resource allocation.
A capacity reservation is basically some kind of activity, which is like production job, for instance, against a specific resource. So it's basically the same as it was in 2009 and previous. Capacity reservation is just a resource that you have selected for the job, and in a certain time period, and then also information about how much you kind of book it.
Like I talked about yesterday, what I see here is a lot of things that are potential answers to the questions I have yesterday. So, resume what I asked there about prioritizing jobs for resource scheduling, about any resource capability requirements and resource capability we're talking about. I want to put in service area for project scheduling and so on. It's not in there now. It's great, but I want to enhance it, of course.
Yes.
And about working times, we have the human resource, what I talked about yesterday. I'm very excited about the rotating shift there. And I can understand it's not in there at the moment in the system, in the business system. But as partners, well, we're used
Yes.
to enhancing the whole thing.
Oh yes.
And well, we're global IT, so we're going to work together a lot on those things.
Oh.
But at the moment, is it possible to work in there? Because my development people are a bit
Yeah.
blind because they don't see the
So what your development people can do is that basically they can modify anything that is in the X++ layer. I will go through and I have an example in the next slides about how you modify stuff. But basically, this is also why the engine is basically just asking for all of this information, because how you generate these working times, right? Right now, we're just using the basic, the normal standard calendar functionality of the resource, where you have the resource to resource group membership, you have a calendar on that one. But if you modify it in any kind of way, you can just send down some different working time to the engine. It doesn't really care, just ask, give me the working time for this resource in this period, and whatever working time should pass, it will just accept those.
The specific modification you asked for is not in C#.
No.
Yeah, but because the engine was closed source for the moment,
Yes.
it was quite difficult when
I'll show you.
guessing that it wasn't finished, but not that we weren't sure.
No, I'll show you a specific example here in just 2 seconds about. So that's kind of, this is the new structure. So we have just to recap, we have the consumers, which is any process basically. They have a representation in the middle layer, also X++ code, which is responsible for loading data into the engine and for saving data back also. So whatever reply we get from the engine saying this is where you should be scheduled, it's up to the X++ code to decide how we should save those. I mean, the engine doesn't know, that doesn't do any saving. It just asks, save whatever I have sent to you back. You can save it now. So the interface to the engine, I know it's a bit hard to read, but I'll go through it. So the idea is basically you start by putting what we call a job to the engine. So a job is, as I said before, some task that should be scheduled. It can have that has a time span, basically. It can actually be 0 length, but okay, for now it has a time span. What you'll do is you can add the time span for that, or the duration of that job. It's basically specifying how much capacity do I need for this job. So in this case, it could be 4 hours, which is actually a number of seconds that you translate it to. You can set this time, you can set that just for the entire job, saying I don't care which resources it's run on, it's the same time it takes no matter what resource, or I can specify for each of the applicable resources I have, what is the runtime on this resource. So there you can modify it with regard to efficiency or whatever you can come up with. So you basically decide what is the runtime of a job. So this is either you specify it when you do the job info, the common one, or you can specify it per resource. Now, each job should have a goal. So a goal is, in this case, it's called earliest end time. This is the case for forward scheduling. It basically means that it will try to pull the end date of the job, so the rightmost edge of the job, as most as possible to the left. So this is the case for forward scheduling, right? So it will try to take the job and have it as far as possible to the left as possible. You can also put an additional goal, or another goal that's called latest start time. It will basically take the job and try to pull it as far as possible to the right. Now, for instance, with the backward scheduling, you would put in two goals, actually. We're using something that we call constraint propagation. This basically means that it will try to fulfill something, some constraints. If it cannot fulfill that, in some levels, it's allowed to drop the constraint again. For instance, for backward scheduling, the classic example is we would like to meet this requirement date. So we start scheduling it backwards from that requirement date. At some point, we hit today's date, or before today's date, then we have to reverse the scheduling direction to forward scheduling. What it will actually do is it will try, the constraint on level 1 will be the latest start time goal. It will try to meet that. If it passes some other constraint, so it cannot fulfill this, it will drop that constraint and just revert back to the other one. What we also have is a number of other constraints. We have, as you can see in the list over there, there's several on them. One of them is jobs end at. This is basically stating when should the job end at the latest. And in the other end, we have job starts at. Now, for instance, we always omit a job starts at constraint as of today, because it doesn't make sense for, at least in our case, for not going before today's date. It could be previous. So these are basically jobs. This is a constraint for the specific job. It's not the links between the jobs. So this is for a single job. What you can also do is, I don't have it highlighted, but you can do something called not on same resource or on same resource. For instance, for the setup job and the process job, they would have this on same resource constraint on them. Basically, it doesn't make sense to set up on one machine and one on the other. So this is just the constraint we omit, saying these two should run on the same resource. We also have one called not on same resource that you would typically do for parallel jobs, because if you run parallel job with infinite capacity, it doesn't make sense. The scheduling engine would just say, hey, I can schedule this job and this job on the same resource. But I mean, you cannot do that. So in this case, you would put in a constraint between these two jobs saying not on the same resource. So back to your questions about customizing. Now, most customizations can be made in the X++ logic without the need to do anything or to extend the managed code. Typically, customizations could be that you have some way of deciding more or less resources applicable to this one. You have your own logic finding out different resources, aid from HR, who knows what. You have different priorities among the resources, so which resource should be selected first. This one you can also customize. You can customize the runtime calculation as we talked about before. You can put in new job types, whatever. The scheduling engine really don't know about job types. So this queue before, queue after, whatever, engine doesn't know about that. It just knows that it has a job and has some constraints. So this is all about what you push into the engine, how you set up the data and feed that to the engine. So an example here that we could have is like expiry days or maximum number of shelf days or something like that. So we have a sales order for a steak at some point in time. The only process for that steak is that we do some defrosting. The problem is, once we've defrosted the steak, we have some maximum number of days we can actually keep it in our own stock to defrost it, right? So the problem is, if we place the job as it's marked here, it would be pretty stupid because we defrosted it too early, basically. So it will expire before we kind of have to sell it or before we need it, actually. So what we want to do is actually that we would like somehow to limit the job to not end before we actually get within the time range of the max days in stock. Right now, there's a constraint in the interface specifying that a job should start after a certain date, basically so that the left side of the job has to be after this date. And there's an existing constraint saying that the right side of the job has to be done before this date. But what we actually want to do is we want to have the ending date be within that time pins up there. So the solution to this is actually that we add a job and a new job, a bogus job or fake job with 0 runtime, but which has some constraints on it, basically saying it's not allowed to start before it actually gets into the max days of stock. What it will happen then is that it will actually pull the other job with it. So we basically add a finish between these two jobs, and it will, because if we do that, it will pull the job towards this end. So this is a way of just omitting new constraints, new jobs. You can heavily modify the behavior of the scheduling. Sorry? Because we have a constraint saying we only have the start date of the constraint. We don't have we actually wanted to trigger on the right edge of the defrosting job. So we just put in a new job and that's it. And then we kind of link them together. So there's lots of stuff you can do with omitting new constraints, changing what constraints you have, putting in new jobs and so on. Of course, you can also, if you wanted, you can have a different calendar than the other one. Or, I mean, you can basically do whatever you want to push new jobs into the engine. If you want, oh, sorry, this is just the code, how it would look. I would put in the new, insert new empty job. There's actually already a method to do that. And then you would add a job link between two jobs, and it would be a finish of a hard constraint. That's kind of it, what you would do. Yes. You have the hard and soft constraint, basically. Hard meaning they have to do this at the exact same time. Soft meaning they can kind of skew like this. So. The empty job, an empty job is not, in this case, it's not consuming any work center. Basically because it has 0 runtime. So doesn't actually need a resource. It only needs it will still need a calendar. We will still need to specify where can it actually run, but in this case, we will have put in the same calendar as the previous job. Okay? Now for the hairy part. Customizing, so customizing scheduling in C#. You can extend the C# code. It's not easy. Let me put it this way. You should only do it if you need new constraints that you cannot in any way combine or get using a combination of the other constraints. What you would do is basically you would create your own kind of inheritance of the existing engine that we've created, and then you would create a new constraint, add that to the new engine, make the existing X++ code use the new engine, and then fire off your new constraint in the X++ code. So an example could be like this. This is again the same. I've omitted a lot of methods that you also have. There's a lot of methods you have to implement in order for the constraint to work. So once you start inheriting from the base constraint, you will see that there's a lot of methods that you will have to inherit to do that, or to basically to implement. So in this case, the main method that you will override is, or you will create a new constraint. In this case, we call it the minimum end time constraint, and you will have to do the propagation. So the propagate method is the one you have to override basically, or make sure you implement that one. And then you would restrict the end time variable of the job to the earliest end time that you kind of pass into your constraint. The constructor of your new constraint would basically be you create a constraint and you have to pass in what time is it that you want this one to end at. Then you have to, as I said before, you have to create your own instance of the scheduling engine or your own inheritance of the scheduling engine. And in that we have a method called add constraint minimum end time, which will basically insert into the engine the new constraint. And you also have to modify the engine adapter. So the engine adapter basically, in order for this to be fast, what we've done is we're not, each time we add a job, we don't call the engine interface because crossing the border between X++ and managed code takes time. So whenever we start hitting on the C# code or calling a C# method from X++, it has an overhead. So what we do is basically we had what we call a command list. So we only had to call C# code once basically with the list of all of our commands, which basically contains the job definition, constraint definition, and so on. So if you create your own constraint, you would also have to make this new, or basically override the add custom commands method to make sure that once you start doing these command lists or processing command lists, that you're sure that you also get to insert the actual constraint. It's a little, yeah, I know it's a little tricky. And then in the X++ code, what you would do is, as you can see in the top, you would basically comment out the existing scheduling engine, put in your own, the reference in the top here, below the green, is the reference to my custom scheduling engine. And then you would have to add a new method to that called add constraint minimum end time, and then in the actual place you want to use it, you can omit the constraint finally. So as you see, it's not easy. And I think most of the customers, I don't think we have talked to anybody who would actually need this. There's always a way to kind of, with the existing constraints, to get around this. Okay? That was kind of it for the scheduling engine presentation. Is there something you feel you're missing? Yes? So,
for example, if I have technicians, and those technicians are service
So what the scheduling engine sees, if I can just go back to one of the on my little nice diagram. Okay. So basically, what the scheduling engine sees, it doesn't know about capabilities. It doesn't know about HR skills. What it knows about is that a resource can have a certain property. We call them in the scheduling engine terminology. We call them properties. It can have a certain property in a certain time period. So this is what it will do. If it will basically ask for what we call resource capabilities here. It's actually the resource properties. And one of the example of a property can be, we even go as far as the type of the resource is a property. I know this will not change over time, but that's also a property. We have type of, yes, we have type of, but type of resource is still a property. A property is also that the resource is a member of a different group. That's also a property. So these kind of resource group memberships is actually just a property that we put on to the resource.
Is there any, I've been having some conversations over to some tickets, and I heard about some documentation being written out to do the analysis. Is there any timeline on when we can have more white paperish use of patterns?
There's actually there are some of these core. So if you look on this on the new information source, there are some new papers out there. These core concept papers. They're most talking about the model. They don't. What I've gone through here is actually put out as a video also. But there is some kind of there are some of the data models you can see. You can see, I actually don't know if the interface is out there specifically. No. Yeah. So, but the main thing to look at, we have made this. It's called I Scheduling Engine Interface, or I Scheduling. I think it's called Work Center Scheduling Engine Interface. It's called. This is basically the class where you can see all the base methods that you can call on the scheduling engine. So I think that's a very, very good start to place to start. I actually in the afternoon I have at 6 I think I have a session about how to debug this, and in this debugging you will actually see more that what it is that we're sending to the engine, because you can debug and you can have it basically log to text files to Windows events or something, log explicitly what is it that we're sending to the engine, all of these properties and so on, and there it will be very clear for you that it's just a property it's sending to the engine. Yes?
You made several changes on the MRP regarding the forecast integrated and the intercompany functionality. What are the results regarding the performance of that compared to 2009?
So if you take the job scheduling part, job scheduling is faster. Significantly faster than 2009. Operation scheduling is somewhat on par with the 2009 solution. It's more because if you saw the presentation I did yesterday, you know that there's now a whole bunch of housekeeping that you had to do in order to actually not overbook, or in order to prevent too much overbooking on the resource groups. This has to find out what is the total capacity per resource type, inside the group, per capability inside the group, and so on. But job scheduling is now significantly faster than it was in 2009. Also because it will actually try, the result of this outcome will actually be that it tries less combinations. And one of the annoying things that was in 2009 was that you could only have the task group, I think it would only try 64 combinations, and then it will basically run out. So if you had to have a group or something, task group that would end up in having to try more than 64 combinations, you would just give up and not try it. Now we have actually put in some new parameters. I think we can do that.
Yes, but to come, yes.
I run X4 2009.
Yeah, 2009.
Okay. And you're using parallel processing, so these help us? Okay.
That's been enhanced somewhat as well.
Yes. So the way it actually distributes tasks among the helpers, before there was a problem that one helper could sit idle for a while the other one was processing heavy items. We have changed the way this kind of this mechanism of fetching items is done.
We had very much problems on that. First runs came to 10 to 15 hours for forecast and MRP. Now we are down to 4 to 6 hours, and that's.
Are you running operation scheduling or job scheduling?
I'm
Yeah,
not
okay.
so deep in
Okay,
that.
okay.
Example.
It's
You can even say forecasting now. If you always in 2009 ran forecast and then MRP afterwards, you don't have to do that anymore. You just have to run an MRP and save it forecast. You save all the time to generating time. So for those companies who have that significant basically the early days you would run forecasting, you would generate all those. Basically just using them for normally no purpose. And flag what should be included in the next master plan. When you want to do a master plan, you point to a forecast plan and you took that one. Now you do that correctly. So within master planning you can just below forecast entry. So the entire time it takes you to execute forecast plan in 2009 is gone. Plus the additional forms. It's not significant, I mean, somewhat.
No, what I want to know is if we have to buy new high-end performance machines just for the MRP.
no.
It's at least at the level of it.
And especially if you in the old days or in 2009 were using a lot of task groups. Are you doing that? Okay. If you're using task groups and you have basically all the hardcore allocating of resources. I'm not talking about the MRP as such, the exploding demand and so on, and doing all the matching against issues. But I'm talking about the hardcore shuffling of resources. In some cases, we saw that was a significant part of that run, and this is a lot faster now.
Significant amount of our customers use job scheduling in master planning because the only way to look for adequate resources was to use task groups. So in the early days, you could find around that you can use this working group, and that was the only option it had. To work around that, you could actually use task groups that only works if you use job scheduling. Then we saw that people would actually use job scheduling in master planning because that's actually where we want to have flexibility, right? So they can use job scheduling in master planning. In that case, the new solution is significantly fun. I mean, for those who use that trick to work around all that flexibility. Now, for another company just running operation scheduling in master planning and not using forecast, you would see around the same way.
I think we're actually out of time.
Yeah, we're a bit.